Hey everyone, Brian Beeler here with Storage Review. I've got a special guest with me today, Richard Kennedy from Qumulo. How are you today?
I'm doing well, Brian. Thanks for having me.
And you've come to us all the way from Dublin.
Yep, Ohio.
Oh, okay.
Yeah.
So you took a shorter,
I took the
shorter route to get here than the aeronautical one that would have to fly you over.
Exactly.
So thanks for coming in. I know we just published the review of the 5-node cluster we've been working on the Qumulo, and it's been really well behaved. It's been good to work with. But we wanted to get together today because we had such a great time with the interface and the UI, and I know that you guys are really software forward in what you do. But before we get too far in, why don't you just sort of explain who Qumulo is, what you guys do, and where you fit in the enterprise stack?
Great. So thanks. So Qumulo, we're a software-defined storage company. Our product can be deployed either on-premise or in the cloud, or a combination of the two. Based in Seattle, Washington. Product's been on the market about 5 years, and the company's been around 7 or 8 years.
Yeah, I've been to the office in Seattle. It's a nice spot there.
Yes, very nice, very nice.
So what we're going to do today is walk through the 5-node cluster that we still have set up in the lab right next door to us. Kevin's running some load against it, so we'll be able to populate some of the meters and the screens and all that sort of thing. And let's just jump into it, and we'll answer questions along the way.
Sounds good.
All right. So let's flip over to the interface. Now this is your starting point, and I'll let you drive because you're the expert here, but just visually, you've got a lot of great just indicators of capacity and activity. I know you guys really take a lot of pride in that.
Right, yeah. The main goal of the interface is to make it simple to see things, simple to manage, simple to use. And when we first come in, the first thing you notice is we see exactly where we are from a capacity standpoint. We can see, this is a 243 terabyte array. You guys are using roughly 10 terabytes on it as part of the testing. We can also see data is coming in at a decent rate.
Yeah, by the way, so you said 240 terabytes in this is 5U. So these are 1U nodes that are highly dense.
Correct. Yep.
Okay.
Yeah. So 5U's of rack space, 243 terabytes.
Okay.
Of real usable capacity. And when we say real usable, you can take this, fill this array all the way up to 243 terabytes. No performance hit. No, you can still expand the array at that point. Basically, you can do everything but write to it. You can delete files off and add more files on. So we have no issues with using all the capacity available to you.
Okay. So when a storage admin comes into this for, maybe not the first time because we're already set up and active, but where are they going to spend a majority of their time in terms of configuring shares and that sort of thing?
I guess it would depend on what they were doing. If they had a ticket and said, "Hey, we just had a big our file folder filled up,"
okay,
they could come in, they could scroll down and look, and they can say, "Okay, well, we just added 150 files, 19 directories. Where did that happen?" And I can drill into this very easily and say, "Okay, there's a load coming. What's going on?" And I can get down here and I can see the top writers right out of the gate. I can see these two IP addresses here are pushing the most IOPS, as well as these ones looking for the most throughput.
So how useful is that, or what are your customers telling you in terms of usefulness of being able to see what's driving the activity on the system?
They find it very useful. They remove the data blindness.
Okay.
So an administrator can come in and quickly pinpoint and say, "Oh, that's coming from this client." And then we can drill in even further if we go into the real-time analytics of this. Whoop. There we go. And I can see, okay, well, there's root. I can click on that and I can see these 3 nodes all the way down to the files. So these are VMDK files being added, moved, changed, and we can quickly and easily find that information. And then if I just want to see, maybe I just care about write throughput, I can turn the other things off.
Okay.
All real time, within seconds, this stuff populates. And then I can drill in even further, and maybe I want to look and see the clients themselves. And I can see you have 6 clients attacking or going against it.
Yeah,
attacking.
Kevin, attacking is right. Anytime Kevin's involved in a lab project, it's always attacking. So he's banging away on this thing with a number of clients, and I don't know, moving files and VMs and doing some other crazy stuff, I'm sure. But yes, you can illustrate all of those from a visual standpoint.
Yep, I can see right there that client ending in IP124, those are the files that it's using the most on.
Okay.
So imagine, you get a call, "Hey, the system's kind of slow, what's going on?" Very quickly and easily, that took, it took longer to ask the questions, I think, than it did to find the answer.
Yeah, and that's interesting visibility because I think in many other systems you've got to dig a little harder to root cause
Yes.
some of those things, because you may have a client that goes rogue and is having some sort of bad behavior, right?
Yep.
And so this will stand out pretty quick. We got a question in. Do your real-time analytics include your cloud extension?
So whether you're on premise or in the cloud, the interface is exactly the same. So if we were living in one of the big cloud providers, this interface would be exactly the same. So we'd be able to see the same information up there.
So it's consuming Qumulo in the cloud, just like an appliance would be if it was in the data center next to us.
Yep. Yeah, we spin it up the same way. We start with a minimum of 4 nodes, go and grow from there, and we do that whether it's your data center or someone else's data center, wherever it is.
Okay. Interesting. We're not even that far in. We've got a question about failures and resiliency. I want to get to that, but let's finish working through the some of the other key visuals, and then we're going to get to the
fun stuff.
Yeah, we'll see if Kevin can cause a failure for us.
So right when we come in, we know there's no failures going on right now because we have the protected shield up.
Okay, so that'll change
if something bad happens.
When something bad happens.
When something bad happens, right. And that bad could be a disk, could be a node, along those lines.
So in our configuration of 5 nodes, what is our protection domain look like?
So the minimum we do is we call it 2-drive protection. We use erasure coding to protect the data. We also protect at the block layer. So files are written into Flash. They sit there and then they get coalesced and serialized down to disk.
Okay.
We use erasure coding to protect at the block level, not at the file level. So with a 2-drive protection, you could be down a node, you're okay. You could be down a drive and be okay. For a drive failure, as soon as we know, typically we when drives fail. The systems call home. We might find out before this drive actually goes away, but we have distributed sparing across the drives, so we can immediately start rebuilding that drive. Large drives typically take, depending on your system, could take days. We say we can rebuild the drives in hours.
Okay. Cool. So where else would someone spend a lot of time? I know I've got a favorite thing. I'm sure you'll get to it, but where else do your users spend a lot of time?
So again, I can look and I can see the balance, where we're, the read throughput, the write throughput, all those things. I can actually see how many clients we have, NFS or SMB. We are multi-protocol, so we support both on the system. Mm-hmm. And if I drill in here a little bit further, a lot of times in the life of a storage admin, maybe they're doing budgeting. It's like, well, how much storage am I going to need? One of the things we look for is capacity trends.
Okay.
And so over the last 72 hours, you guys have grown a ton.
Well, to be fair, the system was idle for a couple weeks, and we just started banging on it. Right. So you'll see a growth spurt. We're not exactly linear.
Yeah. So I can go back 30 days, and I could probably tell when you turned it off.
Right. By the growth dates. Activity. Yeah.
So I can see some changes here. No change data. But typically this screen will be populated with information in there.
Sure.
And I know it's a lab, right?
It is, and it's summer. Being in Cincinnati, we're open air cooled, and so we turn off equipment when we don't have to have it on, and let it sit idle. When it gets to be in the 90s here, it gets a little challenging. It's easier to do in December. Let's just say that.
Yep. Oh, agreed. A couple of the other things that we can look in here. We can go by path. So we can scroll down and say, okay, these are the busiest paths right now. And then I can expand that out and again, find that quick client information.
Okay.
If I go back into throughput hotspots, again, it's similar information, but I can just pick out those pieces and parts and get additional details there, as well as the IOPS hotspots as well.
You're getting a shout out in favor of the UI at the moment. So
awesome. Yeah.
It's there's a lot to like there.
You can run this from your phone.
Yeah.
So depending on your environment, it's very easy. The interface runs on the nodes themselves. You don't need an extra client anywhere. You don't need an extra machine. And depending on which node you connect to is where the interface is running from. So we're actually connected to that address right there.
Okay.
Yeah.
This seems like a good spot to have that accidental failure. Kevin, can you hook me up with a node failure? So it was funny because when I when we were doing the first video for this a while back, when we were getting back into the YouTube thing, we were messing around with this, and by accident, when I was messing with the node, when I pulled it out, I slammed the power button and caused the accidental node failure, which was fine, and it died and threw a warning, and then powered it back on, and it dropped itself right back, and after doing its parity checks or whatever, dropped itself right back into the cluster.
Yep.
Which was pretty neat, because I just told you with our open air cooling, we something bad has happened. We get hot here in the summer, and so we turn off a lot of gear that we're not using. And sometimes, I know this will be surprising to you given your IT background, when we turn things on, they don't always come back nicely.
Right.
So depending on how they were shut down, whether we had a power failure or Kevin's most popular move of just grabbing both power cables and yanking them out with no ceremony or pomp and circumstance, they don't always come back. So I say all that to say that when I accidentally failed a node in the cluster and we brought it back in, it just plopped back in and was ready to go, which was cool.
Right.
So while you're talking about this, we've got the question about resiliency. When you talked about dry failures, now we've failed a node, which is worse. And then there's another question about resiliency around protection at the rack and geo level. So maybe you can think about that as you're kind of talking about what we're looking at here.
Yeah. So one of our core values is Qumulo, we share by default. So we know exactly what's going on. We know this is the node that's down. We know data is at risk. All nodes must be online before it can be reprotected. So we're basically telling you, you need to fix this node and get this thing back online.
Okay. And so at the same time, and I think we're connected to your phone home. So someone's getting an alert in Qumulo organization that we've had a node failure and something bad has happened. So you'll scramble your resources.
They've already been scrambled. So
Okay.
we use Slack as our main method for support. You may have actually got a call from them before you've noticed it was down, depending on what was going on in your day.
Right.
Our support, we call it customer success, and it has each customer has a dedicated Slack channel, a dedicated customer success manager, as well as a group of engineers who monitor that channel. So something like this would pique a lot of ears, and things would start happening very rapidly. Like, hey, what's going on? Is it, is there a hard down? Is it power? What's the deal? And try to figure that out and get it back online as quick as possible.
Okay, so in our current degraded state, though, we're still operational.
Right.
And we're still feeling okay about things.
Yes.
Until we, obviously we want to source this node issue, but otherwise we're okay.
We're okay. Correct. Yep.
Okay, so this is 5. If we think about resiliency as that question was about protection at the rack and then geo, what are additional considerations you have as we think about scalability of these systems?
From a rack or geo perspective, we don't have anything built in to say, hey, node 1 is in rack 1, node 2 is in rack 2, 3, 4. You could easily do that. The one thing we want consistency is we want consistency with the switches. So we like to have top of rack switches and all the nodes into those top of rack switches. But other than that, you could easily spread these nodes out across the data center. From a geo perspective, that's again, how much bandwidth do you have? Can you, give me 25 gig connectivity across a geographically dispersed environment?
So it looks like Kevin's brought the node back online, and now it's doing a rebalancing.
Yep.
And I assume this is super quick because it was only offline for a few minutes, and so we don't have a lot of data. But if this was offline for a day or two in a highly active system, it would take a little while to.
A little bit, yeah. Every environment's different because, to your point, how busy is it? How much data is out there? But a lot of it is just checking. Okay, we use Btrees to control everything. It says, okay, which ones were degraded? Okay, only these 5. Okay, we just need to fix those 5.
Okay.
Or if it was 50 or 100, whatever that number was, our metadata will know which ones were impacted and affected, and let's go fix those ones and leave the other ones that are fine. We don't need to touch those.
Okay. We've got a couple API-related questions. I'll just hit you with both, and then we can sort through it. The first is about the most common API, and then the second question is, are you still API first in your terms of philosophy, and does this extend to the cloud?
So API first, yes. Majority of all new releases, all new features that are released into the software come via API first. And then that's where they're tested and then they'll go GA, and then eventually they'll make it into the user interface.
Okay.
I typically don't go into the API world unless someone specifically asks, which they did. So this is, I like to call it a sampling. Not a sampling, this is everything you can do.
Right.
Everything that we can do on the cluster in this browser, we can do via command line as well.
Okay.
And then there are some things that you need the command line to do that you can't get in for, sometimes I feel it's safety reasons, you can't actually do it in the management interface. Yeah.
More mistakes happen in the GUI than in the CLI, you think?
Potentially, yeah. Because if you click a wrong button, you click the wrong button, but if you type the wrong command, you may or may not have a problem. Our API, I like to think, is a little bit different in that we're not just management with the API. We can move data around with the API as well. So we can do, right now, we just released our product called Shift, and we use our API to do a one-time transfer from our array up to an S3 bucket.
Right.
And as time goes on, that'll evolve into a more feature-rich functionality. But right now, we do it from the array to S3 in native S3 format.
So let's talk about that, because I know Shift, you guys announced a couple weeks ago back in June. I know it's either just about GA or maybe it is now. So two things. Before Shift, talk to me about your development cycle and how you guys are rolling out code iterations.
Yep, so we're an agile shop, so everything's done on typically a 2-week turn. So new code will be, whether it's a bug fix or a new feature, that'll come out. It'll be tested for 2 weeks, and then if it's all good, we roll it out into production. We do quarterly roll-up builds. Mm-hmm. So you could, if you wanted to upgrade every 2 weeks, go for it. Or if you just want to do it once a quarter, that's fine. Or maybe 6 months, whatever your environment needs. Specific features that were coming out, like we just rolled out encryption at rest.
Okay.
So all new clusters will be, all new clusters born today with our newest version of the software, 3.15, will have data encryption at rest on premise.
Okay. So that's cool. And then Shift we were getting into, this is more, and I guess the name implies, data mobility, right?
Right.
So now we're taking data from the array, putting it in object, right?
S3 object, yep.
And now we've gotten the data moved to the cloud where we can do some analytics or use a GPU instance to render something. I don't know.
Exactly.
What other sort of use cases are you finding?
The demo we just did was actually we took a video file, moved it up, and then used some of the services from the cloud provider to put that video into multiple different formats and multiple different definition. We also have customers that maybe they're already in the cloud and want to take advantage of some other features. We can move from one cloud to another cloud with that, or within that same cloud, move it to those buckets and then act on that data.
So with Shift, you guys see this as it's not a replicated copy exactly. It's more like a actionable or transient copy, I guess, where you're going to go move it, do something with that data, and then maybe that's it.
Right, exactly.
Okay.
Yeah. I think that's around the term shift, or shifting it from where it was to where you want it to be, and then doing something with it.
Yeah, we got a question here on Shift on consistency, and I just want to be clear on that point that we're not talking about this as a synchronous sort of element.
Right.
And so I wonder if, because we work with a number of people in video production or something, so you may have a little Qumulo cluster on site, dump your video files to that, and then from there use Shift or something to get it to some GPU compute instances or something to manipulate that, or some of the biometric data, some of the other things that are
correct. Yeah, move up lots of data because it's easy to get there, or from a cost perspective. Manipulate the data in that big set and just bring back the pieces you need, and kind of reduce some of those costs around that as well.
Okay.
Yep. Yeah.
So yeah,
I was going to say Shift is evolving. This is just the first version of it.
Right.
Gosh, we could probably talk about Shift for the rest of the show, but there's a lot going on with it. Yeah.
We'll be back because I know we're gonna do another video where not today, but we'll do it soon, where we do a walkthrough of Shift, how it works, kind of get into that specific functionality.
Right.
Because I think one of the neat things about what you guys are trying to do is say, hey, look, we've got this capability in this NAS basically, and now here are all these other things that we want to add to it to make your workflows more efficient, better, and that sort of thing. And that's neat to see. We don't always see that innovation out of a solution like this. Right. Now, all the talk around updates got me thinking, let's switch back to the UI and then show me, I don't know that we have ever updated this cluster. Maybe Kevin has. What would be the process normally? I'm a little nervous for you to actually hit the button, but
yeah. So software upgrade. I always say, throw a request into your Slack channel.
Okay.
And say, hey, I need to upgrade my cluster. What do I do? And then they'll give you the like, okay, well, you're on this version. We have a repository where you can go out and see the updates and what they include. Say, okay, well, I want to move from 3.10 to 3.13 because 3.13 has a feature I want.
Okay.
So like, okay, download those images, stage them on the array, and then when you're ready and have your maintenance window, we'll all get on a Zoom call and we'll do it together.
Okay. So we'll do a little hand holding.
Yep. Yeah.
Okay.
And we'll the customer success team, they'll talk you through it and just you'll drive.
Okay. So if we were doing that, then we would. What are we on now? Just
2.14.3. Yeah, you're pretty far behind. But to your point, how long have you had the array?
Many months.
Many months.
Yeah. So before the new year.
So we've had, I believe, 2.14. So I want to say 2 major quarterly releases.
Okay.
So we're in the 3s now. But yeah, we would have a process to get you from 2.14.3 up to the latest code or the code that you wanted to use.
What are we missing out on by chance? Is there anything? Well, you talk about the encryption, but there's
the encryption. We've added some functionality for SMB, so you can tie it in with your Windows environment. Use the SMB manager in there. We've added some features around performance. We typically will always have some type of performance enhancement with each major version. Some of the other things, gosh, we do so much.
Well, yeah, there's a lot there.
There is. The performance is the big one. Moving from, I believe at the next release after the 2.14, there was a significant improvement in performance. We changed how we write the data from flash to the disk. We used to use a first in, first out. We changed that to least recently used. So the hottest data is going to stay there. The coldest data is going to move down. It doesn't matter when it landed. It matters when it was accessed last.
So our nodes are hybrid. They're disk heavy. So we're talking about a 1/4 petabyte in 5U,
right?
Which is a lot.
Yep.
Are you guys? I think you're doing some flash nodes and doing some work there. Is that much of a need in this specific space?
We're getting asked for it. So all our nodes, they all have flash in them. We're a flash first. Everything lands there. We do have an all NVMe array, and we have some other work going on in the background that I really can't talk about.
Ooh.
That is going to be some additional improvements on it.
So I'll tell you, this is funny because, a little inside baseball, the Qumulo was a little worried because this isn't a typical engagement, but given our conditions, normally we'd have a corporate marketing guy or somebody doing this pitch, right?
Yep.
So we got a guy that's really in the weeds, like out there with customers solving problems. So you never know what this guy's going to say. He's got all this this intellectual property rattling around in your brain, right? That might slip out on a live cast. So I think corporate probably tightened up a little bit.
They did, yeah, but we do have an NVMe array today.
Okay.
I saw it demoed.
So you know it's real.
It's real. I saw some win reports. Customers are buying them, so there is a need.
Perfect.
But I will say, I'll be the shameless pitch for the sales guy. If you want to know more,
call your sales guy.
Get on our website, get registered, and we'll get in front of you.
We've got a question coming in on your cup, actually. Yep. There's a little orange fellow with a Qumulo flag. What's the deal with that guy?
So that is Grumpquat. Some people will say Grumpquat's never satisfied, so keep driving, keep moving, keep making changes.
Is that what motivates you every day?
I like him because Grumpquat is grumpy, so I don't have to be.
Ooh, okay.
But he is our mascot. We have plush ones that float around corporate. I believe this one has something to do with a space company.
Okay.
But yeah, it's a usually there's a big Lego one somewhere. I haven't seen that one recently, but yeah.
No, we'll have to get marketing to send us one.
Yeah.
All right, so let's drop back into the interface and see what's been going on. So I know Kevin's still running some loads. What else do we have? Oh, so we filled up. We started at 3.7% capacity, I think, when we started this. So he's quickly hammering away on it. What else stands out to you in terms of capabilities of the interface? And now we're getting a little bit more full in the charts.
Yep, we can see, we're doing a lot. You're doing tons of writes, which is good. Again, I kind of call this the easy stuff, but let's see if we got some of the capacity trends. No, they're not populating yet. Yeah, unfortunately. But just from a management perspective, we were on this here. We saw we were down. We're back up.
Yeah.
So quotas or something, we can go ahead and talk about those a little bit.
Sure.
Our quotas are real time. And by that I mean if I went in, created a file share, and set the quota at 50 gigs, and you got a phone call or a ticket, hey, our file share is full. You can immediately go in, change it to 60 gigs, and as soon as you click apply, that quota will be instantly applied to the system.
Okay.
And we do that based on the way we store our metadata. We store that in Flash as well on each node. And then that is where all the Btrees and all that information lives. We don't have to do what's called a tree walk. We don't have to traverse the entire file system to apply a quota that is maybe 15 folders deep or 150 folders deep in a file system. We can do it instantly, right where it's needed.
Okay, cool. So when you're talking to prospects, and what else gets them excited in terms of capabilities in the UI here?
It's really around the analytics, being able to see everything. Oh, we did it.
Yep.
Oh.
So when you give access to this kind of information, like you deal with a lot of IT administrators, right? They're the guys in the nitty gritty. How does this change their workflow and what they do on a day-to-day basis? There
still are folks out there that are managing their data on spreadsheets.
Really?
So they have to look and pull up, okay, last month I ran my report, and I'm, this share is this, and this share, and you're standing there, staring and comparing at spreadsheets. We were able to eliminate all that. Give them time back in their day to do more things. Give them time back in their day to help drive business outcome, as opposed to, hey, I'm just trying to keep the array alive. Really make their life easier. Give them days, cycles back in their day with our APIs and the automation. If they've got a job that they have to manually do every month to move data around, we can automate all of that.
Okay.
If they have, they tie in with their system where maybe they're adding folders and file or folders structures, we can go in and automate all of that. With our snapshots and a replication, we can give them the ability to move the data where they want, use it how they want, and when they want. And really just put the power back in the business of, this is your data, use it for what you want to use it for, and make good decisions, good profitable decisions out of it.
Yeah, we didn't look at snapshots, I don't think, yet. Let's give that a peek while we're talking about it. And we've got, right before you go into that, we've got another question about, do you still offer the OVA for those wanting to try Qumulo and it's shift capable, and what are its limitations?
Great question. So our OVA is a virtual demo appliance, fully functional. It deploys the same way physical hardware would. The only difference between the OVA and either a cloud presence or a data center presence on physical hardware is that it's not supported in production.
Okay.
It's smaller, of course, but there's ways to manipulate that, but it's typically smaller. And yes, you can, every feature and function that we have available in this version, or the fully supported version in the OVA is in there.
Okay.
Yeah, you can, as funny as it seems, you could replicate from a physical to a virtual. It doesn't know. We don't tell you not to because it's not supported, but we don't support production data on there.
Okay.
But yeah, I believe you go out to Qumulo.com/try it now, I think is the site.
Right.
And register, download, and go for it. Yep.
Off you go. Okay. Yeah. So let's show me walk us through some of the snapshot tools. I know it's not something we typically test as part of our review, but there's a little bit of data in there from January.
Yeah. So from a snapshot perspective, we can take a snapshot on demand, give it a name, point it at the directory, tell me when to delete it, and then go. We also have the ability to create policies around snapshots.
Okay.
And one of the new features that is potentially not in your version is our actually continuous snapshots.
Okay.
So we can go and set a policy that either snap on a schedule, and then we have the ability to black out a window as well.
Okay.
We also now have the ability to do continuous snapshots. So as data is changed, we can take a snapshot and then hold that and then have a rolling cycle of those. We can also use those snapshots then to replicate.
Okay.
So we can get pretty creative as far as protecting and moving the data around. You could take a snap, replicate it to another array, and then once that snapshot hits that array, the secondary array or DR, you can actually then go and say, oh, take a snapshot of that as well. So there's multiple levels and multiple ways of protecting that data.
Okay, cool. Maybe we should, we don't really use snaps because it's not in production, but obviously that's another impact of being a little laggy on our on our updates that we're missing out on that.
Right.
All right, I've got another question for you. How full does a node cluster need to be to see performance to be starting to become impacted? So we're talking about degradation of performance at capacity.
Great question. You have an impact on a Qumulo cluster when it is 100% full, and that impact is you can no longer write data.
Well, that's not so much of an impact as a physics limitation.
Correct.
Okay.
Correct. At 100% full, you have two choices. You either delete data to make more room, or you add another node. And we grow one node at a time, and the array can be 100% full, and we can still add another node. That node would come in, join the cluster, and then the data will be rebounced across the new nodes.
So let's think about that. The 5 that we've got, we get to 85, 90% full, and we see the trend because it's on all the time, and we see that chart where our data is growing. We decide, okay, we got to do something.
Right.
Let's get another node, slam it in. I assume we give it IP. We've got to tell it something.
Actually,
right?
you just plug it into the same network initially.
Yeah.
And it uses an IP6 broadcast to find it. You'll give it an IP4 address as well, potentially. Depending on how you set up the original cluster, you do have the ability to pre-dedicate a range of IP addresses. So if we knew
we might add 6, 7, 8, 9, we could
right.
pre-specify those IPs.
Right, and then that node would get one of those IPs. If you didn't do that, which is not a problem, you just assign it an IP. It will be discovered via an IP6 broadcast. You'll actually come in here on this main screen, and it will say new node found.
Okay.
And then you click the button that says, do you want to add? Yes.
So if you go back to our node listing here, let's take a look at that real quick. So it would show up in the cluster. So it would be here, you would see 6, and then this would be where you would see the status of that thing coming online.
Correct, yeah.
And then how does the decision get made at that point once that node comes on? How to balance the data? Because you obviously want to move some stuff to it to take advantage so you don't have 5 full, 1 empty, right?
Right, yeah.
So what does that look like? How does that work?
That's probably a little above my pay grade, but I know how data works.
Right.
So I know it comes in. Again, we use the Btrees. We say, okay, we need to start moving stuff around. So if I had 5 nodes and they were all 100% for easy math for my brain,
right?
They're 20. Just use 20 terabytes each, right? And we want to put that 5th node in, so we went from 120 to 140. There'll be some math in the background that says, okay, each node needs to be 70% full.
Right.
Each node, send a portion of your data as appropriate based on erasure coding. Fill this node up to the same capacity and balance everything out.
Okay.
Right. Yep.
So the follow up from that same question was, in terms of mitigating performance degradation when you get to be full. I think the question is basically, how is that possible? Because I think as storage people, we're used to vendors saying at 80% stop or 90% stop, whatever it is. Don't take it all the way up to the edge because the thing will fall off.
Right.
How are you guys able to do that? It seems like magic-y.
I would say it's the way the code is written, the way we control our metadata. Again, using the Btrees, we don't do tree walks. You will get an alert from somebody. It'll be a person, probably your sales guy.
Sales guys call them way before 100%. Yeah. I'll tell you that much.
So you're going to know ahead of time. But the way the code was written, we are able to use all the space all the time.
Okay.
Yep. And that one, I'd probably have to get one of the software engineers on to go into the weeds on that.
Yeah, and I guess it's important because we're so used to being told that we can't use the whole thing.
Right.
While we're on the scalability topic, we've got 5. We've added a pretend 6th one in this cluster. What sort of scalability limits are there in cluster nodes?
Oh man, we've tested up to 100 nodes.
Okay.
Because that's what fits in our lab right now.
Okay. Sure.
From a theory perspective, we're into zettabytes.
Okay.
Quintillion.
A lot of them.
Yeah, we know today we can put 100 nodes on the floor and fully support that.
Okay.
What we don't know is, okay, what's it look like at 150? We need to do the testing. What's a rebuild look like? What's the communication look like? What kind of network do you have to support that many nodes basically talking to each other?
Well, yeah, at a certain point, it's going to get easier to just segment some of these things off depending on jobs or departments within an org or whatever it is that might need to do that.
Yep. Yeah.
Okay. We've got lots of thumbs up around service. A lot of people are digging the Slack channel for communications.
It's the most interesting thing I've ever seen from a support perspective. No, you can call us if you want. You can email if you want. But you're going right into somebody who's probably going to fix your problem right then and there. They're not going to say, oh, what code are you on? What hardware? We already know all that. The nodes are calling home. We have all that information. Unless you move them, we know where they are. And you're going to get right to somebody who can very quickly resolve your issue, or at least start the process. It's like, okay, what's really going on? And peel back the onions and try to figure out what's going on.
Well, after this, we'll have to find the guy or gal who fielded the Slack alert for when we powered our system up after it being just dead off for a month. And then they're like, why are they running this legacy code? What's going on? We're causing somebody some confusion, no doubt. But on the customer service thing, so there was some support for the Slack bit, and also apparently you guys have recently hired Dave Coughlin as Senior Director of Customer Success, so that there were some thumbs up for that hire. And seems like the concept of supporting the customer and being very hands-on there if they want that's a big deal for you.
Yeah, one of my customers, they'll use the Slack channel for just about everything, regardless of, they're like, hey, we're trying to do this. How do we do that? As opposed to, these guys aren't traditional IT guys. You're a Steelers fan working in Ohio. You probably get all sorts of feedback through Slack if we ever resume football. And the Bengals are hopefully, they can't be worse than last year. You got that kid from Athens.
Yeah, we'll see how that goes. All right, we're nearing the end of our time. I do want to just drop one more time back into the UI and do any sort of housekeeping here on making sure we show anything else that you think is important. I just I know we spent a lot of time on in our testing, and as we were going through the UI, on looking at the performance cluster activity, which I think is really useful.
Right.
We showed the file access and what systems are hitting it. But anything else that we missed that would be kind of in your top 10 or 15 feature list?
Maybe we talk about just creating shares.
Yeah, I guess we sort of skipped past that, didn't we?
It is a file share, right? First time I did, I thought I was doing it wrong. I can type files.
Yeah, I should say we're working at a mild handicap. Yeah. The screen's a touch tough on our older eyes than Kevin's.
Yeah, exactly. And I incidentally zoomed the screen, but if the directory doesn't exist, please create it, give it a name. Description if you want. Good, you do have the code that does handle the access-based enumeration for your Active Directory environment. And if you want to, that encryption is different than the other encryption. This is SMB3 encryption.
Okay.
And then you can add groups. We can tie into Active Directory or LDAP. And once you do that, you go in and put in, if it's a local, we do local / in the name, or if it's a directory, you put in the directory name / and then the group, and then those users would have access. Create the share. If I did it right, I did, and we're done.
Okay.
Super simple. NFS is the same. Go in, set the policies, or set the paths and the folders, and have at it.
Okay.
Yep. Yeah.
Well, I know we talked about upgrades before. We got another question that came in around being non-disruptive. So, do you still do rolling upgrades without downtime?
So our upgrade process today, I've heard the term used called a push-up method. We stage all the software into the nodes. We run in user space on top of Ubuntu. I typically say that wrong. Mm-hmm. But what happens is all the code is loaded up. It's staged. When all 5 nodes or 4 nodes, or whatever nodes you have, say, okay, our code is ready. Let's all restart that service, reboot. We don't. Sometimes we have to go to the BIOS. Sometimes we don't. Mm-hmm. Typically, we don't go to the BIOS. We can do a code upgrade within the SMB timeout window. So we're typically 45 to 50 seconds.
Okay.
Again, things we really can't talk about. We're working on changing that. There is some testing on our all NVMEs, much smaller than that.
Okay.
The windows much smaller, mainly because they're all NVMe drives. Everything's faster.
It helps. Everything's faster. Yeah.
So more to come on that, but we are moving to a world where we'll have some type of non-disruptive upgrade sooner rather than later.
Okay. Well, cool. We've banged through a number of questions. We've gone through so many features of the interface. We've done a lot. I appreciate you coming all the way from Dublin so that we could have this conversation. We're going to actually roll straight into a podcast right after this. I'll give you a chance to take a break, and then we'll punch out our Friday podcast. There'll be more Qumulo talk, so if you haven't had enough, we're going to bank through some more. And always, if you have additional comments or you catch this after the live stream is over, dump your questions in the YouTube comments area. We'll get some support from Richard and his team, or whoever else throughout the Qumulo org. If you've got questions, thoughts, comments, we'll interact there. But for now, thanks again for coming. Thanks again for participating, and we'll be back soon with another event for you.